how early humans adapted to new diets 700,000 years before their teeth caught up. Imagine this. Our ancient ancestors were munching on carbs long before their teeth were ready for the challenge. That's right. 700,000 years before their molars evolved to handle tough plant fibers, early humans were already feasting on grasses and starchy underground treasures. But here's where it gets fascinating. A groundbreaking Dartmouth-led study reveals that this dietary shift wasn't just about survival. It was a bold leap that reshaped our evolutionary path. As our ancestors ventured from the lush African forests into the open grasslands, they faced a critical need for energy-rich foods. Enter graminoids, a group of plants including grasses and sedges, which became their go-to fuel source. But here's the twist. Their teeth weren't yet adapted to efficiently chew these fibrous plants. So, how did they pull it off? Behavioral flexibility. Long before physical adaptations caught up, early humans relied on ingenuity, like using tools to access underground tubers, bulbs, and corms, carb-rich treasures hidden from other herbivores. And this is the part most people miss. The study, published in Science, used isotope analysis of fossilized teeth to track dietary habits. This method bypasses the challenge of studying behavior directly, as behavior doesn't fossilize. Researchers found that hominins, along with extinct primates like therapiths and colobines, began consuming graminoids between 3.4 and 4.8 million years ago, despite lacking optimal teeth or digestive systems. But around 2.3 million years ago, hominin diets diverged sharply, likely due to increased reliance on underground plant organs, which provided a year-round, nutrient-dense food source. Controversial interpretation alert. While some might argue that this shift was purely driven by necessity, the study suggests it was a strategic choice. Early humans didn't just adapt, they innovated. By exploiting these high-energy foods, they fueled their growing brains and populations, setting the stage for later advancements like cooking and tool refinement. This raises a thought-provoking question. Did our ancestors' carb-centric diet pave the way for modern agriculture's reliance on grains like wheat, rice, and corn? Lead author Luke Fannin emphasizes, this shift to underground foods was a signal moment in our evolution. It created a glut of carbs that were perennial. Our ancestors could access them at any time of year to feed themselves and others. Meanwhile, senior author Nathaniel Dominy highlights the secret source of hominins, their ability to exploit grass tissues, a skill no other primate mastered. So, here's the big question for you. Do you think our ancestors' early adoption of a carb-heavy diet was a lucky accident, or a deliberate strategy that shaped our evolutionary success? Let's debate in the comments. Your take could spark the next big idea in anthropology: how diet changes shaped early human evolution. The evolution of early humans was significantly influenced by their dietary changes, a fact that may surprise many. As our ancestors migrated from the verdant forests of Africa into the expansive grasslands, their quest for energy sources led them to develop a preference for grassy plants, particularly grains and the starchy roots found underground. However, a groundbreaking study led by researchers at Dartmouth reveals that these early hominins began indulging in these carbohydrate-rich foods long before their teeth were adequately adapted for such a diet. This research marks the first time evidence has emerged from the human fossil record, indicating that beneficial survival behaviors can arise prior to physical adaptations that facilitate them. The findings were published in the journal Science. Shedding light on a fascinating aspect of human evolution, https://www.science.org/doi/10.112 science.ado2359. The study's authors conducted an analysis of fossilized hominin teeth, examining carbon and oxygen isotopes that indicate the consumption of graminoids, which encompass grasses and sedges. Their results showed that ancient humans were inclined to eat these plants much earlier than the evolution of their teeth allowed for efficient chewing. It took an additional 700,000 years for evolutionary changes to manifest in the form of longer molars. Similar to those found in modern humans, which are adept at breaking down tough plant fibers. According to Luc Fanon, a postdoctoral researcher at Dartmouth and the lead author of the study, these findings suggest that the adaptability of early humans played a crucial role in their survival, even in the face of physical limitations. We can definitively say that hominins were quite flexible when it came to behavior, and this was their advantage, Fanon explains. In anthropology, we often discuss behavioral and morphological changes as if they evolve in tandem. However, our research indicates that behavior can independently drive evolution, significantly impacting the dietary and physical development of hominins. Nathaniel Dominy, the Charles Hanson Professor of Anthropology at Dartmouth and the senior author of the study, emphasizes that isotope analysis provides a solution to the long-standing challenge of identifying the origins of new behaviors, as behaviors themselves do not fossilize. Anthropologists frequently infer behaviors based on morphological traits, but these traits can take an extensive amount of time, sometimes over 500,000 years, to appear in the fossil record, Dominy notes. These chemical signatures, however, are clear indicators of grass consumption that are not reliant on morphology, he adds. They reveal a significant delay between the adoption of this new feeding behavior and the eventual need for longer molar teeth to effectively chew and digest tougher plant materials. The research team examined the teeth of various hominin species, starting with Australopithecus afarensis, a distant relative of modern humans, to trace the evolution of their diets over millions of years. They also compared these findings with the fossilized teeth of two extinct primate species that coexisted during the same period. Therapiths, large terrestrial monkeys resembling baboons, and colobines, smaller monkeys that primarily consumed leaves. Interestingly, all three species shifted their diets from fruits, flowers, and insects to grasses and sedges between 3.4 million and 4.8 million years ago, despite lacking the optimal teeth and digestive systems for processing these tougher plants. The study found that hominins and the two primate species maintained similar plant-based diets until about 2.3 million years ago, when a sudden change in carbon and oxygen isotopes in hominin teeth indicated a significant dietary shift. This drop in isotope ratios suggests that Homo rudolfensis, the human ancestor at that time, reduced its grass consumption and began to rely more on oxygen-depleted water sources. The researchers proposed three potential explanations for this shift, including the possibility that these hominins consumed significantly more water than other primates and savanna animals, or that they adopted a lifestyle similar to that of hippos, spending much of their time submerged in water and foraging at night. However, the explanation that aligns best with what is known about early human behavior is that later hominins gained regular access to underground plant organs, such as tubers, bulbs, and corms. These underground structures also contain oxygen-depleted water, which many glaminoids use to store carbohydrates safely away from herbivores. This transition from grasses to these high-energy underground plant tissues would have been particularly advantageous for a species experiencing growth in both population and physical size, according to Fanon. These underground food sources were abundant, less dangerous than hunting, and provided essential nutrients that supported the development of early humans' expanding brains. With the advent of stone tools, ancient humans could easily dig up tubers, bulbs, and corms, facing minimal competition from other animals. We propose that this shift to underground foods was a pivotal moment in our evolution, Fanon asserts. It created a surplus of carbohydrates that were available year-round, allowing our ancestors to nourish themselves and their communities. The analysis of hominin teeth revealed a consistent trend of reduction in size, shrinking approximately 5% every 1,000 years, while molars grew longer. This indicates that the dietary shift towards graminoids outpaced physical changes for the majority of their evolutionary history. However, the study found that around 2 million years ago, with the emergence of Homo habilis and Homo ergaster, the trend reversed, as these species exhibited a rapid change in tooth shape and size that was more suited for consuming cooked foods, such as roasted tubers. Graminoids are prevalent across various ecosystems, meaning that wherever hominins roamed, they could maximize the nutritional benefits derived from these plants as their teeth became increasingly efficient at breaking them down. Dominy highlights a critical question in anthropology. What did hominins do differently that set them apart from other primates? This research suggests that the ability to exploit grass tissues may be our unique advantage. He further notes, even today, our global economy relies heavily on a few grass species: rice, wheat, corn, and barley. Our ancestors made an unexpected move that fundamentally altered the course of species history on Earth. For more detailed insights, refer to the study by Luc D. Fanon et al., titled Behavior Drives Morphological Change During Human Evolution, published in Science, 2025. DOI 10.1126, Science ADO 2359, https://doi.org/10.1126, Science ADO 2359. This content is intended for informational purposes only and is subject to copyright. Any reproduction without written permission is prohibited. How eating grasses transformed our ancient ancestors' teeth. Human evolution. Imagine our ancient ancestors weren't just surviving, they were thriving on a diet of grasses, a habit that reshaped their very teeth over millennia. Sounds wild? It gets even more intriguing. Recent discoveries reveal that hominins began feasting on grasses, grains, and their underground treasures long before their teeth evolved to handle these tough, fibrous foods. This evolutionary lag raises a fascinating question. Could behavior like diet choices actually drive physical changes in our species? And if so, how did this play out in our ancestors' journey from forests to open grasslands? Let's dive into this twist on human evolution and the surprising role of dirt-digging dinners. The grassroots of change. Picture this. Around 3.8 million years ago, early hominins like Australopithecus afarensis began abandoning the safety of forests for the vast, sunlit grasslands of Africa. With their usual fruit-filled diet suddenly scarce, they turned to an unexpected menu. Grasses, their grains, and the hidden carbs stored in roots, tubers, and bulbs. But here's where it gets controversial. Studies show they were munching on these plants millennia before their teeth caught up. This gap between behavior and biology hints at a key evolutionary concept called behavioral drive, where actions like foraging habits shape physical traits over time. Luc Fanon, a Dartmouth researcher involved in the study, calls this adaptability a superpower. Hominins weren't stuck in one way of living, he explains. They could pivot their diets and behaviors long before their bodies fully adapted. This flexibility, he argues, might explain why hominins outcompeted other primates during this pivotal era. But what exactly triggered the eventual shift in their teeth? The answer lies buried in the fossil record and in a clever use of chemistry. Digging for clues in isotopes. To unravel this mystery, scientists turned to the teeth of ancient hominins and their primate cousins. By analyzing carbon and oxygen isotopes left behind from meals, they could trace dietary shifts without relying solely on tooth shape. These chemical signatures are like a dietary diary, says Nathaniel Dominy, another study co-author. They tell us what animals ate, regardless of how their teeth looked. The results were eye-opening. By 3.8 million years ago, hominins had swapped forest fruits for grasses. By 2.3 million years ago, they were digging for underground carbs, like tubers, resources with minimal competition from other animals. Yet their teeth didn't fully adapt until 700,000 years later, when species like Homo ergaster developed narrower, longer molars, perfect for grinding these tough plants. This 700,000-year gap between diet and dental design is what the team calls an adaptive lag, a period where behavior led the way and physical traits followed. The secret sauce of survival. So, why did this shift matter so much? For one, underground plants offered a steady, calorie-rich food source that could be accessed year-round. This wasn't just a snack, it was a game-changer, Fannin says. It gave our ancestors a reliable energy boost, fueling bigger brains and social cooperation. But here's the twist. Other primates, like monkeys, also started eating grasses around the same time. Yet they never made the leap to underground foraging. That's the million-dollar question, Dominy adds. What made hominins different? This study suggests our knack for exploiting hidden resources might be the answer. Food for thought. This research challenges long-held assumptions about evolution. For decades, scientists assumed tooth shape was a direct reflection of diet. But these findings show behavior can outpace biology, creating a feedback loop where actions drive changes over time. And this raises a provocative idea. Could similar behavioral drives explain other human traits, like walking upright or tool use? Or is there a limit to how much behavior can shape our evolution? We'd love to hear your thoughts. Do you think early hominins' creativity with food was the key to their success, or was it something else entirely? Share your take in the comments below. After all, the story of human evolution isn't just about bones and teeth. It's about the choices our ancestors made, one grassy bite at a time.